Okay, so today I'll show you this project, and as you can see I have a touchscreen keyboard, and if I type in something, for example world, and then press the enter key, this thermal printer will print the message, which makes it a typewriter, right? Sort of. And I like this project for a few different reasons. First, it's very simple, and second, it's not using Arduino or any other microcontroller. It's just this screen, which is a next-gen intelligent display, and this thermal printer module. And it's just a nice coincidence that both of those modules speak the same language. So today I will show you how to do this project, but before I do so, let me tell you something, and actually let the thermal printer tell you something. Yep, that's right, this video is sponsored by PCBWay. And just this month, PCBWay is celebrating their 9th anniversary, which means that you can get a lot of stuff with great discounts, including PCBs, flex PCBs, 3D printing or CNC manufacturing. So, happy birthday PCBWay! Okay, so back to our project. If you want to follow along, you will need two things, or actually three. You will need the next-gen display, and I've made the project for the resolution of 800 by 480 pixels, but also for 480 by 272 pixels. And there are a few different series of those displays, and you can easily tell it by the color of the PCB, so the blue one is the basic one, black one is the enhanced one, and the red one is the intelligent one. And the good news is that you can use any of those, so you have quite a lot of displays to choose from. The second thing is the thermal printer module, which I've already tested in one of my older videos. If you haven't seen it, I would suggest you to do so because it has all the important details. And there's actually one more thing that will simplify the development quite a lot, and that's this USB to TTL converter, which is a USB to serial communication module, and it only costs just a few dollars. And before we start putting together the keyboard, let's do something very simple, for example printing something on the printer. And just because the printer uses the serial communication, we will use the printer together with the USB to TTL board. For that communication, I will connect RX to TX and TX to RX and also ground to ground. There are two more wires, but we don't need to connect those. There is a separate wire for the power supply, because this printer requires a power between 5 to 9 volts, and the bigger voltage you provide, the nicer will be the print. So I will use the external power supply and provide 9 volts. Finally, I will connect the USB to TTL board to my USB port, and we can start printing. For that, we need some serial terminal application. There are a lot of applications to choose from. My favorite one is called RealTerm, and it's free, just in case you were wondering. In here, I will switch to the port tab and select the correct port, which usually is the highest one. In my case, that's port number 11, and I need to set the correct speed, which for this printer is 9600 bauds. All the other settings should be left to default, so I'll just unclick and re-click this open button, and hopefully that will open the communication. Since I want to see what I'm typing, I will jump to display and click this half duplex mode. Then click up here and type in, for example, hello world, and press the enter key. And immediately as I press the key, you will see that the printer printed something, but it's not visible until I click this button to move the paper slightly. And now we can see that it really printed hello world message, so just like that we can print something. And as you've just seen, it didn't print anything until I've actually pressed the enter key, which sends the CR character, which stands for carriage return. And that means new line, but usually the new line could be either CR or LF, which is line feed. So if I go to the send tab, I can send a message from here. So for example, hello, I don't know, universe. And I can select which end of line characters I can send after pressing this send ASCII button. So I can send CR, which is carriage return, or I can send LF, which is line feed, or I can send both. So let's try sending both and send the ASCII. And you can see that as well, something was printed. So if I press this button, you can see the message hello universe. So let's do one more test and maybe say hello YouTube. And this time we will only send the LF character, so not send the CR, only sending the LF, and press the send ASCII. And same as last time, we also see the message hello YouTube, which means that we have quite a lot of freedom in sending the message. We can either use the CR character, CR-LF, or just the LF character, and in all the cases the message will be printed on the printer. Again, the only important part is to make sure that the serial speeds are matching. In the case of this printer, that's the 9600 bauds. So the next step will be not sending this message from your PC, but rather from the next-gen display. For that, I will temporarily disconnect the printer and connect the next-gen display to the USB to TTL board. The connection is very similar to last time. RX goes to TX and the TX goes to RX. And this time I can probably use the power from the board itself, so the 5 volts goes to 5 volts and ground goes to ground. After that, I need to install and run a dedicated application called the next-gen editor. In here, I will create a new project by clicking this new button. And after selecting the file name, I need to select my display. Currently I'm using the intelligent one in the resolution of 800 by 480 pixels in the size of 5 inch. So I'll select this one, click the display and select the orientation. I want the horizontal one, and I will probably go with the 180 degrees because that's the one where the connector is on the right side. Click the OK button and we have a new project created. For testing the communication, I want to create a button that once clicked will send a message. So I'll click the button icon here on the left side and that will create me a button. And even when I see that inside the attributes, the text is set to new txt, I don't see anything in here. And that's because there is no font in our project. And so as a result, if I would click the compile button, I would see that error saying there is no font in your project. So the first things first, we need to add a font. And that's done by clicking the tools and the font generator. And this utility will create a font for the next-gen display from any of your fonts on your system. And even when I know that the final font will be most likely different, I will start with some default one, for example, Firacode. Now what this utility is doing is that it's taking the TTF file from your system and basically converting this into a series of small images for individual glyphs, which means that we not only need to set the font, but we also need to set the size of the font. So for example, I don't know, 32 should be fine. And we need to set which of those characters we should include in our font. Range is set to all characters. I think that I'll lower this to ASCII characters. And for the encoding itself, let's select ASCII as well. I will keep this anti-aliased and I will select the name of the font, and you can set any name, but it kind of makes sense to use the name of the font and probably the size. Click the generate font and that will generate the font file inside your specified folder. I will use the same name and click the save button. It will tell you the font size and it will ask you if you want to add the font into your project, which is something that we want. So I'll click the yes button. And now as I close the dialog and I jump to fonts, we should see that we have some font in our project. And so as soon as I click the button, you can see that now it changed and we can see the font. So I'll change the text to be, for example, send serial message. And it says string too long. So we need to first set the TTL max length to maybe, I don't know, 64 characters. And then change the text again to send serial message, something like this. Now, as soon as we click the button, this event called touch press event will be called. So we want to send the message from here, but we first need to know what will be the correct command. And for that, I will go to help and select instruction set. That will open the page with all the instructions. And I already know that our instruction starts with print. So I will search for print. And I think that's the one. So print S is the command that we are looking for that will send formatted data over the serial to the MCU. There are some examples down here, and I think that this one is something that we are looking for, so that will send some string, and the second number sets the number of bytes. We want to set this to 0 to send all the bytes. So I'll copy this line into our NextGen editor and paste it in here, and let's say hello world from NextGen. Again, 0 for sending all the bytes, but this alone will not be enough because it will only send those individual characters. It will not send the line ending. So for that we need to send 2 more characters, the line feed and the carriage return. And if I open the ASCII table, the carriage return is the ASCII value of decimal 13, and the line feed, the new line, is the ASCII character of decimal 10. So inside the NextGen editor, I will say print S, and I want to print decimal 13, only 1 byte. That will be the carriage return. And then again, print the ASCII value of 10 in decimal, again, only 1 byte, and that will be the line feed. Before we put this on the display, we can actually test this application inside the built-in editor if we click the debug button, and that will run the same design inside this simulator window. So if I click the send serial message button, something appears down here, and if I click this S character, that will change the output from hex to string and should show us hello world from NextGen 0D 0A, which stands for 13 and 10 in decimal. Again, that's the carriage return and the new line. So let's close this window and upload this to the NextGen display. And there are 2 ways how to do that. You can go to Tools, TTF file output, click the output button, and then copy this TTF file to the micro SD card and put it inside the NextGen display and restart the display. But since we have the display connected to the USB to TTL board, we can as well click the upload button and upload it directly to the display. And just because I know that my connection port is number 11, I don't need to auto search. I will just force this to become 11 and click the go button. And this will connect to the correct port, and in a few seconds it will upload this design to the display. So now we see our button on the display itself, and if I click the button, you will see that this small LED on the USB to TTL board lights up, and this LED is RX, which stands for receive, so it's receiving some signal, but we don't see anything on our PC because we are not showing those messages. So let's one more time run the real-time application, set the speed to 906,000 bauds, that's the default speed for the display, the port should be 11, close and open the connection, and now if I click the button on the actual display, it should show me the same message on this output. And I can click this button multiple times, and every time I click the button I will receive the message together with the CR and LF characters. And since we know that everything works, let's connect the display to the printer. With every NextGen display you will get this small PCB, which is for converting the power from the micro USB into those header pins. And that's what we will use to power the NextGen display. I already have the printer connected to the external power supply, so we need to connect the serial lines between the NextGen and the printer. And there is a small catch in here because both of those have the female header pins, so I have to use additional set of wires with male pins on both ends. Again, the connection is RX to TX and TX to RX. However, we also need to connect the common ground, and I already have the ground from the next-gen display connected to the USB power supply. So I've created this strange looking jumper wire that I can use to connect the next-gen to the ground, but I also have this additional wire which I will connect the ground to the printer module. So with everything connected, now it's a moment of truth. I press the button on the display and the printer indeed printed the message. So it looks like that everything works as expected. So what we need to do now is to turn this button into multiple buttons and construct a keyboard. But let's start simple, and that is by only having few of the buttons from the keyboard. Inside the next-gen editor, I will move this button to the side and maybe make it smaller because I don't need it anymore, and create few more buttons by clicking this button icon, maybe button A, B and C, so this will be button A. I will change the text to A, copy paste the button, this will be button B, and one more time and this will be button C. Now with pressing those individual buttons, I want to change some text, so for that I will add a text component by clicking this text icon and maybe make it much bigger, for example like that, and of course increase the maximum number of characters, which is the txt max length, to for example 64 characters. And so now when I press the A button, I want this text to add the A character, so I will say T0, which is the text object name .txt equals some value, and actually not equals but plus equals, so I want to add something. I want to of course add the character number A. I can do it like this, or I can use the text from this button itself, so it will be B1, which is the name of the button .txt. And so now when I press the debug button to test the code inside the simulator and press the A button, the character A will be added to the label. And I can do the same thing with buttons B and C, so just copy this one. And for button B, I will add the B2 text because that's the name of the button, B2. And for button C, I will add B3, which is the name of the button C. Again, click the debug button, and now I can add A, B and C individual characters to the text itself. Now, since we know how to add individual characters, let's add some special symbols. So I'll copy this button one more time, and this time I want to make it a space character. So for the text, I will, for example, type in underscore character, and instead of adding the value of the button, I will simply add a space character. Another special button might be a backspace, so I'll copy this button and change the label to be, for example, something that resembles a backspace character. And instead of adding something to the T0 text, I want to remove one character. And if I look into the documentation, this could be done by calling minus equals, which will remove a specified number of characters from the right side of the string. And here are some examples. T0.txt minus 4 will remove last 4 characters. And since we only want to remove one character, we will say T0.txt minus equals 1. And as I run it in the simulator, I can add characters A, B and C as well as the space. And I can also delete characters by pressing this backspace button. Just like that, I can go all the way to not having any characters. To send the string to the printer, we'll reuse this button, but instead of sending the predefined hello world from next-gen message, we will actually say the content of T0, so we'll say T0.txt. We will send all the bytes, and of course we want to include the character turn and the line feed, and that should be enough for our simplest possible keyboard. Again, running the debug, I will delete everything and type in ABC space CBA, click this button, switch to the string, and we should see the message ABC, CBA and new line. And after uploading this to a next-gen display, we have the simplest possible keyboard, obviously with a very limited number of keys. But adding the new key should be just a matter of copying the button, changing the text and adjusting the code slightly. Hopefully it's something that you know how to do at this point. However, before I create a full keyboard with all the individual keys, let's create some kind of design or images that will be used for buttons, because the default gray ones are kind of boring. Thankfully, the next-gen editor has a very simple way how to create image buttons and how to simplify the process. Instead of having separate image for every individual button, we can have one image that will have all the buttons in the unpressed state and the second image that will have all the buttons in the pressed state. So in the end, we will only need 2 full screen images. Let me show you how this works. So I have 2 images, one with the image of mountains and the second one with the image of Aurora, and I will add those images inside the pictures. I will click the add button and add those 2 images inside our project. For all the buttons, I can change the style from solid color to be the crop image, and then the pick C will be the up state, so I'll browse and select, for example, the mountains to be the up states, and the pick 2 will be the down state, so again I will browse and select the Aurora to be the down state. Hit the OK button, and now when I run the simulation clicking the debug button, as I press those individual buttons, on the down states we will see the image of Aurora, while on the up state we will see the image of those mountains. And so the position and the size of the button will set which part of the image to show, because this is a full screen image, and we are setting the area in which we want to display the button. So if I make this button much bigger, you will see that now I see much much bigger part of the background image. Again, hit the debug button, and now this image is like almost half the screen size. So just like that, we can cover all the individual buttons with just having two images, two full screen images. But we need to first create those images, because as much as I do like mountains and auroras, as I select the page and set the page background color to be also the background image, so image and the pic will be number 1, and I will do the same thing for the text, so the style will be a cropped image, the pic will be 1. At this point it will be impossible to see the boundaries of those individual buttons without actually clicking. So I think that the background looks nice, but I want to have some kind of borders around individual buttons. And to draw those buttons, I will use a free online editing tool called Figma and start with a new design file. In here, I will draw a new frame, so select a frame and draw a frame. And I will set the size, which should be 800 by 480 pixels, of course. And let's rename this frame to Nextgen keyboard 800 by 480. I want to have some background picture, and what I would usually do is to go to the Pexels website and try to find some nice photograph. But what I can also do is inside of Figma, I can click this button for resources, and inside plugins type in Pexels and then open this plugin to run the Pexels plugin, which makes it much easier to insert pictures in here. In here, I will search for example, Aurora, but I can search for anything else. Find the picture that I like, for example, this one, and then just click and it will be inserted into my canvas. I will zoom out a little bit so I can see my Nextgen keyboard frame, and I will resize this picture to be much smaller, for example like this, and then move it inside our frame. Then zoom in and adjust the size of the picture just so it's filling the space nicely. For example, something like that should work just fine. I can close the Pexels plugin for now and continue with the individual buttons. And before I do so, I will most likely lock this layer so I cannot accidentally click it. Let's draw the grid for the individual buttons, and for that I will zoom in a little bit more and then select the rectangle tool, which is this one, and draw a rectangle, for example 2 by, I don't know, like 70 pixels, so 2 by 70 pixels. Maybe zoom out a little bit and then move the rectangle so it's touching the frame from the outside like this. So this will be the first line for the grid, but it's now outside of the frame itself, so we want to move this inside our frame and then create a copy by dragging this with Alt and Shift key pressed and hit the Ctrl D button to continue with duplicating this line multiple times. And I want to duplicate it 12 times, so I have 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I have 11 spaces for individual buttons. Then I will select all the rectangles, and you can see that there is this slider in here which I can use to adjust the spacing in between those rectangles. And of course I want those spaces to be as big as possible in a way that the last line is also outside. But as you can see, this is outside, but there is also 1 pixel gap, which is probably something that I can live with. So this will be the final spacing, and if I select one of those rectangles, click the Alt key on my keyboard and hover over another rectangle, I can see that the spacing is 71 pixels. I will zoom out and select all the rectangles and actually group those together by hitting Ctrl G button and move those a little bit to top, and then create 2 more copies. So I'll just drag this group together with the Alt key pressed, move it to be touching the previous one and maybe 2 pixels more to the bottom, and do this one more time. So this will be the first, second and third row of buttons. I want to offset the second row by a half of the key, and since I know that the spacing is around 71 pixels, I can move it to around 35 pixels to the right side. So 1, 2, 3, and then 1, 2, 3, 4, 5 will be moved by 35 pixels. And then I can draw those horizontal lines, so selecting the rectangle tool and drawing a rectangle that will be sized 800 by just 2 pixels, and move it to be touching the upper part of this grid, and then create a copy to be in between the first and the second row, and then again copy to be in between the second and the third row, just like this. Then I will select everything, group it together and move it so it's touching the bottom of the screen. So using the shift and down arrow and then down arrow alone to move it by 1 pixel increments. And I think that something like this looks nice. Now those 2 last buttons on the second row will be just 1 button, that will be the enter key. So I will double click this rectangle, actually 2 more times, and then hide it using this eye icon. And I will do the same thing for those 2 buttons because those will be also merged, and this will be used for the space character. So again, double click this rectangle and hide it. And I can also rename this group to be grid. It's probably also a good idea to log the grid, and let's add those individual labels. For that I will click the text button, click anywhere on the canvas and type in Q, maybe make it slightly bigger, for example, I don't know, like 36 points, and of course make it center aligned by clicking this text align center button, and then move it to be in the middle of the first button, for example like this. Make the copy by dragging the layer together with the Alt and the Shift key pressed and move it to the center of the second button, and then click Ctrl D to duplicate it 1 more time, actually 11 more times, like so. Now if the spacing is not so perfect, you can always select all those individual letters, zoom in a little bit more, and then adjust the spacing by dragging this in between slider, but I think that in this case the spacing looks perfect. So I will duplicate this group 2 more times to the second row and 1 more time for the third row, and now I can double click the individual labels and type in the correct character. Let's change the font by selecting all the labels and selecting a different font. And I believe in my case, I was using a font called Lexant and I was using Lexant Light. And let's also change the special keys to have some symbols. So maybe, for example, instead of having a smaller than symbol, have a proper backspace symbol. And instead of having the enter label, let's have a proper enter icon. And I know that, for example, font Fira Code has a lot of nice icons. So I will open the character map and look for some icons. And I believe I will find the one for the enter key, which could be this one. So I'll copy this in the clipboard and paste it in our Figma file. And of course, make sure to set the Fira Code font. So that will be the enter key. And I will do the same thing with the backspace key. So this will be for backspace. Actually, it seems like that there is some symbol in the Lexant, but I will switch to Fira Code instead. And let's find one more icon for the shift key. And I believe this one will look nice. So this will be used for the shift key. So again, paste it and change the font to Fira Code. I think that I will keep the 1, 2, 3 for switching into the digits and special symbols, but I will make it, for example, bold and a little bit smaller. For example, I don't know, like 20 or 24 points instead. So it looks like an icon. Now, as for the space character, I will actually draw a standard rectangle. So I'll draw a rectangle and then click this icon to edit the object and select the top line and simply delete it. Now, it might look that nothing is there. Rectangle is still there, but there is no outline. So I'll click the stroke effect and add a new stroke in the white color and maybe 2 points, just like that. Then I will click the done button to end the editing and adjust it slightly as for the size and position to really look like the space key. I will group those individual layers by selecting first the special characters by clicking on those with the shift key being pressed and then hitting the Ctrl G on my keyboard. So those will be the special characters, and lock the layer for now, and then select all the other labels and again group those together. Those will be standard characters. And the reason for doing it like this is that for the final export, I will actually not show the standard characters because those will be inside the Nextgen editor, but I will still use the special characters, so those will be displayed. Anyway, let's keep all the labels displayed for now and let's work on the keyboard itself. I think that for this particular background image, it might look better if the grid will be darker color instead of white, so I will change the fill to be black and lower the opacity to maybe like 30%. And another way how to increase the clarity of those individual labels is to blur the background slightly. And we can do this quite easily inside Figma by inserting a new rectangle and drawing it by the bottom of the screen, for example like this, then lowering the fill to maybe only 1% and applying the effect that will be the background blur effect and increasing the blurriness to maybe like 30 pixels. Obviously we don't want to blur everything but only the background, so I'll move this rectangle below everything except for the background image and rename this to blurred background. And I think that it looks much better now. Let's do one more thing, and that is to highlight the enter key because this is the most important key in our keyboard. So I will draw one more rectangle that will be the size of the enter key, like so. Then move it below everything else and change the fill color. And this time I will use the eyedropper tool and select one of those green colors. Maybe something like this will look nice. Maybe make it a little bit more saturated. And I think that this is nice color for the enter key. The next step is to create a preview of our string. So I will select the text tool and type in, of course, hello world. Make this center aligned and align it to center on the canvas and maybe increase the size to some very big value. And maybe we can make it slightly bolder by switching from light to regular font face. So this is how the keyboard should look like when nothing is being pressed, and we need to create one more variation with all the buttons being pressed. So I will select the top level frame, which is the Nextgen keyboard, and just drag it to the side with the Alt key pressed, which will create a copy. And for this one, I will rename it to Nextgen keyboard down to indicate that this is the down state for the buttons. And let's just quickly change how this looks like. And I think that I can use the blurred background layer to increase the opacity of the fill layer and maybe change the fill to use this green color from the enter key. Maybe mix it with the background a little bit by lowering it to, I don't know, like 70% of the opacity. And for the enter key itself, let's change this to white color and the actual character to be, for example, a black color. So the icon will be black. So there is a difference between the unpressed and the pressed state. Finally, it's time to export those images. So I will select the top level frame and on the right side, I will click the export button and I will do the same for the second frame. So again, select the frame and click the export button. And I can click this button and it will actually export me the PNG image, but I have to do this separately for each individual frame, which is of course not that much because I only have 2 frames. But what I can also do is go to the main menu and select File, Export. And you can see I have 2 images to be exported. So if I click the export button, that will export me the zip file with both of those images. In either case, it's time to use those images inside the Nextgen project. And I cannot just remove those images from the picture menu because those are being used. But what I can do is I can replace those by clicking this replace button or this replace icon. And for the first image, I will select the up state. And for the second image, I will select the down state. you can see there is no change on the canvas until I actually click something, or maybe until I select something. And you can see I have those images in the arrow way around. So I want the unpressed state to be image number 0. So for all the images, the pic C should be 0 and pic 2 should be 1, as well as for the new TXT. So the pic should be 0, as well as for this big button on the bottom, which might look kind of confusing because this button is really huge. Let's move those buttons to some better places. For example, this will be the first button, even though the label is not matching. Second button, for example, like this. Third button in here, and it's just mainly for testing. So if I click the debug button, I should see the down states of those buttons as I click those individual buttons. Now it's time for adding more buttons, but what I would like to do is to start from a blank page so that the order of those buttons is somehow logical, so that will be button 0, 1, 2, 3, and so on and so on. So what I can do is I can add a new page to this project by clicking this new page icon, or actually add page icon, but it will add a page 1. So if I restart the simulation, you will see that I still see the first page being displayed as a first page. So what I can do is I can click this icon to move the page 1 to be the first page. So now when I restart the simulation, the blank page will be the first page, and the name of the pages are kind of confusing. So I can just rename those to be the keyboard, and this will be the helper page that I will delete later on. So for the keyboard, I will select the page and set the page background to be the image. And of course, it will be the image number 0. And then I will create a button, so clicking the button and move it to the right position and making it the correct size. Of course, the style should be the cropped image. The pic 0 is 0 and the pic 2 is image number 1. The PCO and PCO2 are the colors of the labels for the unpressed and the pressed state, and I want both of those to be white. And then the text should be capital Q. And we can check the correct size and the position in the Figma file by drawing a helper rectangle in the size of the button, for example like this. And we know the size should be 72 by 72 pixels and the position should be 0 and 265 pixels. So the 0 and 265 is correct, but the size should be 72 and 72, so we are almost right. The next steps are obvious, but at the same time a little bit tedious, because you have to duplicate the button, set the new position and the new label, and check the size, because some of those buttons have slightly different size. And as you can see, for now I'm only covering the standard buttons. And the reason for using the default button names is because I want to later on reuse those buttons to not only print uppercase characters, but also lowercase and maybe some special digits and symbols. As you will see in a second, for all the special characters, including the space button, I will set the string to be empty because it will get the icon from the image. Let's copy and paste all the special buttons, and again for all of those the text strings should be empty. That's the property txt. And in this case I will actually use custom names for those buttons, so the backspace will be b_backspace, the shift button will be b_shift, enter key will be b_enter, and switching to the other layout will be b_num. Before we hide the characters from the background image, let's add the proper font in our project, so I'll jump into the fonts menu, and what I haven't showed you is if you double click the font, you will see all those individual glyphs, those individual images that are being stored. So what we want to do is add a new font, going to the tools, font generator, and we were using the font called Lexent Light for the keyboard, and the size was roughly 40 points, so I will go with 40. Again, changing this to ASCII encoding and ASCII characters, and setting the name to be Lexent Light 40 points, generating the font, using the same name for the file, clicking the save icon, and making sure that I click the OK button, or actually yes button. I want to add this into my project. While I'm creating fonts, I will create one more that will be Lexent regular, actually just a Lexent, in a very big size. I was going with 110 points, and that will be for the big label. Same settings except for the font name, generating the font, saving it and adding it to our project. Then I can close this dialog, and for all the buttons I will set the font to be font number 1, so ID 1 for the font. And you can see that it's almost matching the background picture. And then I will create a new text because we don't have this component in here. Make it much bigger. Set the maximum number of characters to 64. Set the style to be the cropped image, and the image will be 0. The text of the font will be white, and the font will be ID2 with those big glyphs. So I will set the font to be font number 2 and maybe change this message to hello world. It's slightly smaller than the image on the background, but I think it still looks nice. At this point we can jump back to Figma, and for both the up state and the down state we will hide the hello world message, and we will also hide the standard characters because those are already in the NextGen editor. We will only keep those icons, and then again going to the main menu and selecting file export and exporting those two images in the form of a zip file. Going back to the NextGen editor, going to the picture menu and replacing those images by clicking this replace icon with the images without labels. So this is the up state and this is the down state. Again, the canvas is still showing the old pictures, but if I click something, it should update itself. And if I click the debug button, I should see all the buttons, how they should look like. So I can click those individual buttons and you can see the down states for every single button, including the enter key, backspace, and all those special symbols. And while we can see the down states, at this point the buttons are not doing anything, so let's just fix this. And we already have the code on our helper screen, so if I open any button, we have this t0.txt plus equals b1.txt, so I'll just copy this piece into my clipboard, and I want to paste this into the button touch event. But usually what happens for touch buttons is that you don't get the action until you actually unpress this button. So instead of pasting it into the touch press event, I will paste it into the touch release event. So if I paste it in here, the t0 equals b0 actually .txt and restart the simulation. As I press the button, I will see the down state, but I will not add a new character into our string until I actually release the button. And so now the Q is being displayed in here. So let's just paste this code for every standard button. And of course change it to match the button name. I will also borrow the code from the space button, which is this button, so that will be adding just one empty space, and that this is our space character, and from the backspace character, which is removing one character. Finally, I will also copy this send serial message code into our main keyboard, so for the enter, I will send the content of the text 0, together with the carriage return and line feed. And so as I restart the simulation, most of the buttons should be working, including the backspace key and all the individual characters. But the buttons that are not working are the shift key and the digits key. And I've actually created those in the wrong way, because if I click the shift key, I want the shift key to stay pressed, same with the 1, 2, 3 key, but it's not the case. So for those two buttons, instead of using standard button component, we have to use a different component, which is called a dual state button. And so what this button does is if I click this button, it will stay pressed, and if I click it again, it will be unpressed. So that's actually what we want for the shift key and for the digit key. So I will delete the old shift key and use the same properties for the new shift key. So the style will be cropped image is 0 and 1, no text, and the same position and size as before, and the name should be b_shift. Also delete the digits key, copy and paste the shift key, move it to the right side, and change the name to b_num. So as I restart the simulation, as I press the shift key, it will stay pressed, and as I press the 1, 2, 3 key, it will stay pressed as well. We just need to add some logic, and the logic will pretty much say that if I press the shift key, I want to change the labels for all the individual buttons, because what's happening is that I'm using those labels from those buttons to put this into the main string. And we can read the pressed state of the shift button by looking at the value property. So 0 is unpressed and 1 is being pressed. So inside the code, and I will make it a little bit bigger so I can see more of the code, I can say that if the shift key is being pressed, so meaning if b_shift that value equals 0, in this case I want to set the labels for those individual buttons to be lowercase characters. So b0.txt equals lowercase q, b1.txt equals lowercase w, and so on and so on. Now if the button shift is pressed, so else, then of course I want to show the uppercase characters. So again, the b0 will not be the lowercase, but it will be the uppercase q character, and so on and so on. Now, since we are currently showing uppercase characters, I want the shift key to be pressed by default, so I'll set the value to be 1, and then we can debug and restart the simulation. And if I unclick the shift key, I should see lowercase characters, so now it should be typing lowercase characters. And if I press the shift key, I will be typing uppercase characters. Now what I want to do is if I have the shift key being pressed and I press any button, any key, I want to turn off the shift key once the character is added. So inside the button, let's start with the Q button. I can say that if the shift key is being pressed, meaning b_shift that value equals 1. In this case, I of course want the b_shift that value equal 0. But if I restart the simulation and press the Q key, the Q is being added, the shift is being unpressed, but actually those characters on those individual buttons didn't change. And that's because we are just changing the state of the shift button. We are actually not triggering the touch press event for that button. So in the Q button, instead of saying b_shift value equals 0, we want to simulate clicking on the shift button, and we can do this by calling the click command. So I want to click on the object that will be b_shift, and the second value is whether we want to simulate press event or the release event. And since I have the code inside the press event, I will select 1. So when I restart the simulation now and I click the Q key, the Q character will be added to the string, and at the same time the shift key will be unpressed and all the characters will turn to lowercase 1. So all that's left to do is to copy this piece of code for every single button. At this point, the only button that's not doing anything is the 1, 2, 3 button, which should be switching the layout to digits and maybe some special characters. So let's just fix that. And we will use a very similar technique as for the shift button. So we will say if the b_num button value equals 1. That means that we want to show layout with digits and special characters, which means that the B0 text will be digit 1, the B1 text will be digit 2, and so on and so on. If the 1, 2, 3 key is unclicked, so we'll say this else. In this case, we want to set the labels based on the state of the shift button. So I'll just pretty much copy the code from the shift button into this piece of the code of the 1, 2, 3 button. And so if I press the debug button and then press the 1, 2, 3 button, it will switch the layout to digits and special characters. Now what I want to do is if I have the 1, 2, 3 button being pressed and then I press the shift key, I want to unclick this 1, 2, 3 button. So inside the shift key in this code, I will pretty much unclick this button by saying bnum.value equals 0. And I will do it for both cases. So one last debug session, I will delete some words so I have some space. And let's type in, for example, YouTube, then switch to the 1, 2, 3 layout and type in some exclamation mark or whatever I want to do. And I can see that everything works as expected. If I keep typing, you can see that everything goes outside of the screen and I no longer see the label, but that could be easily fixed by going to the text properties and making sure that the wrap line is set to 1. That's the property is BR, so we'll set the word wrap to be true and maybe make it slightly bigger so the second line will also fit like this. Again, click the debug, and as I type in something, it will jump to the next line. Now we are almost finished, but let's talk about a few more things. The first one is the memory usage. So if I zoom in this area, you will see that we have pictures taking half of a megabyte, some fonts and some other data, which results in a file size of 1.2 megabytes. Now for this particular board, the flash size is 128 megabytes, so we have quite a lot of space. And even when we use a different display, not the intelligent one, but the enhanced, the 800x480 version of the enhanced has the 32 megabytes of RAM, and for the basic one, that one has 16 megabytes of RAM. So even for the most basic one, we have still plenty of space for other images. So what I've done in my original design is that I've included a lot of themes and a button to switch between those themes. So if I click the debug, there is a button on the right top corner, and if I click this button, you can see that I have different themes to choose from, and I believe I have 10 of those, so you can see those individual themes. I've tried to went with dark background, so I don't have to change the color of those buttons. Those could be always white, but you can do this if you want to. It will just make the code a little bit more complex. I've also added a small animation when the enter key is being pressed, so when I press the enter key, timer will be called and it will remove individual characters from this message, so it looks like that it's being sent to the printer. And here is the timer. You add the timer by clicking this timer icon, so there's a timer icon. It will add this timer where you set the timer interval, and in the code for this timer, this is actually not true. I'm calculating the length of the string by calling the string length function, and if the length is bigger than 0, I'm removing first character from the string. Otherwise, I just disable the timer. I still have this second screen which I've used for testing, and I can switch between those screens. I have this invisible button in the corner. This component is called hotspot. That's basically a button but without any image, so that's just the area on where you click. And if I say page 1, it will switch to page 1. So if I go to debug and click this corner, it will jump to page 1, and then I can jump back. Also, the page 0 doesn't have to be the one that's being displayed when you power on NextGen. If you open the program.s, there is a line saying page 0. If you change it to page 1 or any other page, and then you restart the simulation, that will be the first page to start with. But I will change it back to page 0 because it makes sense in this case. This is how the Figma file looks like. Not only I have different themes, but I also have a different resolution of 480 by 272 pixels, and this one on top is 800 by 480. Now the great thing in Figma is using components, and that's signalized by this violet outline. So if I click this one, this is actually the main component, and this one is the instance. So inside the main component, if I do something, for example, hide those characters, it will be done for all the instances. So this way I can just hide the characters for all the individual themes, and I can do the same thing with the small resolution. And with just 2 clicks, I have all those images prepared for the background for importing into a NextGen project. As always, there is a link in the description of this video which leads to the GitHub page where you can download all the assets, including the NextGen source files for different displays, as well as the Figma file. And that's pretty much it. If you have any questions or comments, please put those down in the comment section. If you have any ideas of what you would like to see on my channel, please let me know as well. Thank you very much for watching, and I hope to see you soon. Thanks and bye.